as far as what JPL and NASA expect to learn is it's basically how a new form of storing energy will work in space. This is a very important experiment. I mean, it's not just a toy. This will affect future missions as well. With a system like this, we can get cold, we can still operate, we can go further into space, farther away from the sun, and do more important things. It's going to fit on a rocket in basically a little tiny box, and the rocket will be launching some very expensive big satellite. And we're along for the ride. My name is James Flynn. I'm a part-time professor here at California State University, Northridge.
My name is Dr. Peter Bishay. I am an assistant professor at the Mechanical Engineering Department at CECS. Senior design projects are mainly a project where the students for the first time apply the knowledge they gained in all the previous courses they took in the Mechanical Engineering program. It starts in the fall where they start doing research, analysis, and design, computational design, and then at some point they will go to the next step and start manufacturing, assembling, and then testing the product they are doing.
My name is Neil Mendoza. My job here is a technician, however, basically the staff machinist along with my colleague Cesar Crisostomo. The machine shop is available for the College of Engineering students as well as computer science. So basically I'm a machinist by trade. I've been a machinist before here for about 10 years, I guess about 12 years total since I've been here for about 2.5 years. As well as my colleague Cesar. We're both formerly trained machinists, but we're here basically to manage the machine shop.
My name is Cesar. I actually manufacture parts for engineering students here in Jacaranda.
The students who created this plane say the process starts with an elaborate plan.
Figuring out the size of it, and then from there you go into the structural part, make sure that the components can handle those stresses, and from there it's the manufacturing side and then the testing.
But they were faced with a big problem before the competition.
Our aircraft got stolen along with the truck and the trailer it was with, so we had to start all over. We actually finished this airplane at 7 a.m. today.
We have 30 years experience racing Formula SAE combustion cars. We typically have anywhere from 25 members. The Society of Automotive Engineers decides a new rule book. We have to carefully read over the rules. Then we begin our preliminary design phase where we look at last year's concepts for the combustion car, and once that happens, we begin the critical design phase where we do the design synthesis and analysis of the vehicle itself.
We basically start with the previous year's car. Our first step was, well, what's going on with this one? Why does this one exist and why is it the way it is? Everything's built from the ground up. Our chassis guy, he would take a bunch of PVC pipes and I'd tape it all together and make a design with our chassis. And you just keep iterating and then eventually bring it all into a master assembly. We get it laser cut and we weld it here in-house on our chassis table.
We currently have 3 Haas machines that allow us to make the car as lightweight as it is. In order to do faster lap times, you want the car to grip better.